This is Alfa test stand number 3. It was activated in 1955. This is sacred ground. I was transferred to the development group in 1955 and assigned to this area. I worked in the office over in Area 1 where we had the meeting, they had office building. But the test, there was 2 organizations in operation primarily. The development group that I was in and the test group that actually had the responsibility for testing the engine. They would, we would write the test requirements. We had control of the configuration of the Atlas engine. We defined the instrumentation and the type and duration of the tests. We specified everything. We were responsible for its safe operation and making sure that it met specification. The test group was responsible for conducting the tests, for providing the test stand, all the facilities, the power, the gases. They put the instrumentation on. They added parts if it had to be, or replaced parts. They brought it out from the pre-test building, brought it out on like a dolly. This center piece here would come back on the rails. They would put it on, move it out, and mount it to the truss mount. This is the Atlas missile. It was 75 feet tall and 10 feet in diameter. It shows the 2 boosters and the sustainer engine, which we fired here. But we never fired, when I was here, we didn't fire the cluster. The stand isn't big enough. We'd either fire the boosters or the sustainer. This is an engineering marvel. The tanks on the missile are the missile itself. They're like, for example, on the V2 that the Germans built, you had like a fuselage, if you allow me to call it that, and propellant tanks inside. The propellant tanks on the Atlas were the missile. They were very lightweight. They were 2/100ths of an inch thick of stainless. That's half the thickness of a dime. These were so thin that they had to keep the tanks, even when it was empty, pressurized at all time, or it would just collapse of its own weight.
Wow.
If you will, think of the tanks like a Coke can.
Wow.
In fact, about sometime around 1957 or so, I was in flight support, and they blew up one of these at Edwards Air Force Base. And my buddy Walt Greenwald and I were sent out to the Mojave Desert to walk around underneath the test stand, picking up pieces with the assignment to determine what was it that caused the explosion. And I came across a piece of the tank. You see it's been discolored by heat and bent from the pressure. But this is the material that was used to build this. So we were constantly doing a cut and try thing. We'd run a test, look at the pressure measurements, look at the flow, and then say, shucks, let's go back and try it again. Nowadays, they have computer programs called engine balances. You put in the characteristics, the flow character, the ducting and so forth, and the computer program will tell you the flows and pressures throughout the system. In 1955, we didn't have computer programs. We didn't have computers, but we had notebooks with charts, and we had slide rules. This is the Ferrari of the slide rule. This is a Kufel-Nesser log duplex decitrate. And for example, to use it, say here's 1600 times 2100. That's 3,660,000. There it is, right there. You can see that. Now, the problem is it doesn't give you the decimal point, but if you've done the problem more than once, you know where it is. The upside is it took no batteries. After a test, well, at the cutoff of a test, there's what we call blowback. When you shut the valves, the pressure in the combustion chamber, because you've shut off the propellant flow, generally it might flow back through the injector. In fact, some of the fuel or carbon or carbonaceous materials could get back into a LOX passage. And LOX and carbon are incompatible. It would be unthinkable to run a second test on that engine if you suspected there was any particle of fuel anywhere in a LOX passage. In fact, when liquid oxygen was accidentally combined with kerosene, it formed a gel like a little gray-brown jello. And I've heard many stories, because we would send a mechanic in after every test inside the thrust chamber to check for burning. And I've heard stories that the mechanic would look up at the face of the injector, and there was this little puddle of this grayish-brown jello. And it's shock sensitive like nitroglycerin. If you were to hit it, it'd blow it. So he would very carefully get out, and then we would flush the engine with trichloroethylene, which was the solvent of the day. Everybody was using it. You could buy it in any hardware store. We used millions of gallons. That tank over there had the trichloroethylene. We didn't put it on with a garden hose. We've been bringing it in with tubing, but nevertheless, in the early days, because it was not considered to be any great problem, they'd let it go out into the flame bucket. The flame bucket is a chute. You may have seen one in the video. That goes down. There's a big hole here. You can't see it, but it goes into the flame bucket and goes out there, and there's a settling pond. During the test, thousands of gallons a minute are pumped into the flame bucket to keep it, because if the flame hit if the water flow were interrupted, the flame bucket will melt like butter. So they cool it with water. And after each test, when they were cleaning with the trichloroethylene, they'd let it go down into the flame bucket, into the settling pond. Later they captured it when they realized it would be a good idea. And Paul will tell you more about what Boeing is doing about the trichloroethylene. But I used to clean it up here to clean my necktie. And some of the guys said they used to wash their hands after lunch or something. He's smart, you know.